Hello students, in this video we are going to see what homologous series are. There are so many series, but what do we know about homologous series? Before going into that, to understand that, we need to know about hydrocarbons. What are hydrocarbons? Very simple. Hydro, so hydrogen. Carbon. So hydrogen, a compound containing hydrogen and carbon is called as hydrocarbons. Now coming to this, there are three types mainly: alkanes, alkenes and alkynes. Okay? Alkanes, alkenes and alkynes. And they all are a group of compounds which have the same, this is called as the general molecular formula. So N stands for the number of carbon atom. In the previous video we saw about the root word. Just remind yourself, come back to this now. N is for the number of carbon atoms. So here we have CnH2n plus 2. Let's work it out. If N is equal to 1, in this case N is equal to 1. If it is CnH2n plus 2, then the formula would be CH4. That will be the formula for this methane. It is CH4. Now that means this methane's formula would be CH4. Now let's go to ethane. What is ethane? N is equal to 2. So if we are following the same formula here, it would be C will be 2, H will be 2 into 2 is 4 plus 2 is 6 here. Okay, so let's write it out. C2H6. Got it? Now let's go to this. Propane is N is equal to 3. So C would be 3. And what would be hydrogen? 2 into 3 is 6 plus 2 is 8. Okay, so we'll fill it up here. C3H8. Alright, now let's go to butane. N is equal to 4. So C would be 4. What would be H here? 2 into 4 is 8 plus 2 is 10. So H10. Again we fill it here, C4H10. Okay, now we go to the last one, pentane. Now N is equal to 5. How do we work it out? C will be equal to 5 and 2 into 5 is 10 plus 2, 12. So H12. This is the formula. So C5H12. Okay, now let's see the difference here. Let's go to this. What is the formula for ethene? Okay, if we go to ethene, eth, the root word is eth. Eth means the carbon atoms will be 2. Therefore, N will be equal to 2. So, C2H4. Let's write it here. C2H4. Okay. Now next one, prop. Root word is prop. When do you say prop? When there are 3 carbon atoms. That means N will be equal to 3 here. Therefore it is C3H6. Okay. So C3H6 here. Let's go to the next one. Butene. But. What is but? Root word is for 4 carbon atoms. Therefore, N is equal to 4. Apply that over there. C will be 4. H would be 2 into 4. That is 8 here. C4H8. Okay. So, C4H8. Done. The last one over there, pentene. Pent. Pent is the root word when N is equal to 5. Pent stands for 5 carbon atoms. Now let's apply that. It would be C5 C5H10. Let's write it here. C5H10. Did you understand this? So, when we apply this general molecular formula, we get these as the specific molecular formula for ethene, for propene, for butene, for pentene. These are all double bonded. These are all alkanes which are single bonds, and alkynes will start with ethyne again. Now you would ask me why this does not start with methene and methane. Okay, they need a double bond. When can we form a double bond? A double bond can be formed only between two carbon atoms. It cannot be formed with hydrogen. Hydrogen has only one electron. It cannot form a double bond. Okay? Or a triple bond also can be formed only between two carbon atoms. So the minimum requirement for a compound to form, for a double bonded compound or a triple bonded compound, is two carbon atoms here, and here also we need two carbon atoms. That is why we start with eth and we don't start with meth over here. Okay, now let's work out this accordingly. Let us see how we get the molecular formula. See, now when we work out according to this formula, CnH2n minus 2. If n is equal to 2, 2 into 2 is 4, minus 2 becomes C2H2. This one has C3. So 3, 2 into 3 is 6, minus 2 becomes 4 here. This is propane. C4. 4 into 2 is 8, minus 2 is 6. So that is butane. Similarly, C5H8 is pentane. Now let's move into the similarity of this. If we subtract, say, methane is there, CH4, and ethane is C2H6. What is the difference here? It is only one CH2 group. Just add the CH2 to this, you get C2H6, right? Supposing we want to go further. Let's say ethane, C2H6. If we have to add CH2 to this, just one CH2, and you get C3H8. Okay, let's try again. Let's try this one. Butane is C4H10. Okay, if we are going to add another CH2 here, you will get pentane. So you got it? So what is a regular pattern? There is a regular pattern of successive members differing by a CH2 group. Okay, and all these members have the same general molecular formula. That's very important. So general molecular formula is the same, and the successive members differ by a CH2 group. Now let's move on to this. Okay, let's see here. Ethene. If we add a CH2 group, you get propene. Okay, if we add another CH2 group to this, what do you get? Butane. So see here, when you add CH2 to this, C3 plus 1C is C4. H6 plus 2H is H8. Okay, if we add another CH2 here, you get pentene. From butane, you get pentene. So actually what is happening? It's added by a CH2 group, or if we take the mass of this, one carbon atom has a mass of 12 atomic mass unit. Hydrogen has 1 atomic mass unit. So 2 atoms of hydrogen together make 14 AMU. So there is a jump of 14 AMU for every compound, every successive member. The same rule applies here also. Just we'll try one here, ethane and propane. C2H2, when you add one CH2 group, you get C3H4. And it's the same for everything. So what are the 2 points? Same general molecular formula. That's point number 1. Point number 2, they differ from the successive members by a CH2 group. That's very important. And because there's a regular increase in mass, the physical properties also have a regular structural pattern. There is a gradation in physical properties, but similarity in the chemical properties. That is what is called as homologous series. What does this mean? It's a series of organic compounds. Point number 1. What do they have? They have the same general molecular formula. The whole group has the same general molecular formula. And what is the difference? They differ from the successive member. Successive means the following member. By what? By a CH2 group. Okay? And they have a regular structural pattern. So this only is known as homologous series. Having seen the homologous series, we quickly move into the more about hydrocarbons. We should know about this before we enter into the IUPAC names. Okay? So when we go into this hydrocarbons, we should know 2 terms, saturated, unsaturated. What do you mean by this saturated and unsaturated? Saturated means all the 4 bonds are satisfied with other elements. Okay? That is saturated. If there is not enough, then what happens? Between the carbon and carbon, temporarily there is a bonding. That is when a double bond or a triple bond will form. Okay, double bond or a triple bond. These are called as unsaturated compounds. So 2 types, saturated and unsaturated. How does this happen? Let's just take an example, a few examples from each. Okay, we saw just now that alkanes have a general molecular formula CnH2n plus 2. Okay, alkenes have CnH2n and alkynes have CnH2n minus 2. This is a general molecular formula. Now, based on that, the first compound is methane. How do we write the structure? There is 1 carbon atom and there are 4 hydrogen atoms. Therefore, we draw the structure this way. So, this is the structure of methane. Now, let's go to ethane. Ethane has 2 carbon atoms. Therefore, C and C here. Okay. And each one can have 3 hydrogen atoms like this. Let this be for methane. This is ethane. Is it satisfied? Yes, because it has 1, 2, 3, 4. This carbon atom has 1, 2, 3, 4. All the 4 bonds are satisfied. They are called saturated. Now let's go to the unsaturated alkenes, starting with ethene, which has only 4. Okay, so there is a carbon, another carbon atom is there. Now it has 4 hydrogen, which is shared among the 2 carbon atoms, 2 each. And there is 1 here. Supposing it needs 1 more bond. Okay? Like, it is like you can have 3 apples or 3 bananas and there are only 2 bananas left. Then what happens? You have to adjust with whatever is available. Like that. So there are only 3 bonds. 1 more bond has to be done. So there is a double bond that is formed here. This is temporary. The moment you get another, the bond breaks and it is satisfied or it becomes saturated. Let's see 1 more. Propene, 3 carbon atoms. Okay, so 1, 2 and 3. There are only 6 hydrogen atoms. So there is a double bond somewhere and 1, 2, 3 hydrogen atoms and 2 hydrogen atoms here and 1 hydrogen atom here. Now see here, supposing it is like this. Is it satisfied? Is it saturated? No. Why it isn't? See here you have 4. This carbon atom has only 3. This carbon atom also has only 3 bonds. So what should it do? Temporarily there is a double bond that is formed. Okay. Now let's go to alkynes. This has C2H2. So only 2 carbon atoms and there are 2 hydrogen atoms, one on each side. So there is naturally a single bond between this and one more bond here. Is that enough? No, because carbon atom needs 4 and there are only 2. So to make up, it forms a triple bond over here. So it forms, both the carbon atoms together form a triple bond. This is called a triple covalent bond. Okay. Now see here, this is a single bond. This is a double bond. This is a triple bond. We can try this in this also. Supposing there is a triple bond here. Only one more hydrogen atom is required here. This carbon atom does not require anything and this carbon atom needs 3 more like this. So this is how the structure goes. Now see here, there is a triple bond formed. These are the 3 different ways. Why these are formed now? Suddenly, if an element comes, say another hydrogen atom or molecule comes, what would happen? Each carbon atom would grab one and instead of C2H2, it would add that to hydrogen to form C2H4. So it's going to add. Let us take this one. This is C2H4. If another hydrogen molecule comes here, it would add because it's already running short. It needs to, therefore it adds to form C2H6. So it's addition happens. But when it comes to this compound, let us take this compound, okay? Let me just draw this clearly for you. See here, there is hydrogen atoms, 4 hydrogen atoms on all the sides. Supposing one chlorine atom comes here, do you think it will add on? No, it's already saturated. It's already satisfied. So what would it do? It will say, this chlorine would come, hey, hydrogen, you go away. So one hydrogen is gone and one chlorine comes in. That is called as substitution. You've seen this in cricket matches, don't you? Cricket match, football match. If somebody wants to be substituted, they will not be part of the ground, in the ground. They would come out and a substitute comes in. That is called as substitution. So in this place, there would be one chlorine here, like this. So that is substitution. See, that's what is happening here. So alkanes have single bonds. Electrons are not available. Therefore, they are very less reactive. And the name itself, there's another name for alkanes as paraffins. Para means very less or little. Affins is affinity. So it doesn't have affinity. It's like you're having your stomach full and you don't want any more. And therefore, it would undergo substitution reactions only. Okay? But when you come to alkenes, they have electrons available. In wherever double bonds are there, the electrons are still there, waiting for some element to come in. So when that element comes in, it adds on. Therefore, it undergoes addition reactions. Why does it undergo addition reactions? Finally, to form a saturated compound. Same thing happens here, okay? And in this case, there is a triple bond. So more electrons are available. Okay, therefore, it's more reactive than alkenes. Alkanes are the least. Alkenes are reactive. Alkynes are more reactive than the alkenes. Now, this also will undergo addition reactions, but step by step. Little it adds and one bond is broken, another element is added, another bond is broken. So these are the basic differences among the hydrocarbons and especially among saturated and unsaturated hydrocarbons. Next we move on to nomenclature in the next video. Therefore, stay tuned and keep watching. Share. Don't forget to like, share and subscribe to this channel. Bye-bye.